All right, friends, let's look at triangle congruence proofs. So we just spent an entire lesson looking at how do we know if two triangles are congruent. Easy peasy, right? Well, the next part is how do we prove they're congruent? And you're like, Miss, I don't really understand what you mean by that. I just did that. I told you that they were congruent. I showed you. Let's get specific. Our learning target today is I can write proofs. Your job today is to be able to write proofs. And we're going to be focusing these proofs on triangle properties. So if you have been in the advanced courses, you've been writing proofs for a while now. Today we're going to focus on using the triangle properties, however. So the question is, what the heck is a proof? So again, if you are in advanced, this might be something you've already been doing, but for those of you who are on level, this is probably your first time to see a proof. So what is it? A proof is basically, it's an explanation. It's you teaching to somebody else how you figured something out. It is all the thoughts in your brain logically on paper. That's all it is. It's not crazy magic. It's just your thoughts and your explanation. Here's what I love about proofs, and I really, really do. I get real nerdy about proofs. I love them. That's one of the reasons I'm excited to teach this lesson with you. It's one of the few things that you will do for the rest of your life, whether you realize you're doing it or not. At some point in your life, you may choose to live a life where you have kids, right? And you're gonna have to teach your kids something. And you're going to know all the answers in your head, but that kid is not. And you're going to have to logically get them from here to here. And that's what a proof is. You're going to show somebody how to cook something, and you're going to have to get them from here to here, right? You are going to have a job, and they're going to hire somebody new, and they're going to be like, hey, show them the ropes. And you're going to have to show that person how to get from here to here. This is what proofs do. They show your knowledge, right? How did you do that on paper? It's like when you're in a class and you're watching your teacher do steps and you go, whoa, 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 teach. Why'd you do that? And the teacher goes, I will tell you why. Let me show you why. That's what we're doing when we write a proof. We are showing why we are able to do something. Okay? We're just doing it with words. It's kind of cool. So every proof has a beginning, middle, and end. So the beginning is where we write down everything that is given to us. Something's just given to us, like, here's a thing. Cool. The end is our proof statement. Like, we did it. We did the thing we were trying to do. The middle, those are all our logic steps. Okay? Logic steps. And notice I say logic steps and not just steps. They have to logically go in a certain order. You can't just leap from one thing to the other unless it is logical. Okay? Now, for the sake of our lesson, when we talk about why are you allowed to do something, we're going to call that thing a reason. And these are a lot of the reasons that we will be using. So we know about vertical angles. Cool. We know what midpoints are. Cool. We know what bisectors are. Cool. Reflexive, that's a little bit new, so we're going to talk about that one. And in our last lesson, we learned about all these ways to know that a triangle is congruent to another triangle. So a lot of our reasons, a lot of our whys, we know. So let's just kind of walk through one, and I think you're going to see this is not scary. Okay. I don't want my reasons to go away. There we go. So here's an example. I am given that AD is congruent to AB. So notice that's not on my picture. So the first thing I always like to do is draw on my picture. So AD is this one, and it's a segment, and it is congruent to AB. So I'm going to put tick marks. I could use a single tick mark if I want to, but I used double. DC is congruent to BC. So those are these. So I guess I'll do singles over here. All right. So those are drawn. My job, or my goal, is to prove that triangle ADC, triangle ADC, so this top triangle is congruent, exactly perfectly matches triangle ABC. Now, some of you are already like, oh, duh, miss, I know this already. I did this yesterday. Ah, hold the phone. And that's cool that you do. We today are not just saying, yes, it is congruent. We are going to write down all the steps and the reasons why I know it's congruent. So statements are kind of like, what do I know? And why do I know it? Or how do I know it? Okay. Why do I know it or how do I know it? Okay. So what do I know? We always start with the beginning, which is our givens. So I'm going to write AD is congruent to AB. And my reason is it was given to me. I don't need any other explanation. They gave it to me. Check. All right. I also have another given, so I'm going to go ahead and get that one out of the way. All right. So when I'm trying to solve that two triangles are congruent, remember these are my rules. So it's sides and angles usually. So it looks like I have two sides. That's exciting. I either need a third side or an angle of some kind. I got nothing about angles right now. But that side, AC, in the top triangle looks a heck of a lot the same as it does in the bottom triangle. Right? Like it's kind of the same as itself. So this is what we call reflexive. Right? Something is the same as itself. So here's what we would write. We would write that AC is congruent to AC. It's congruent to itself, which sounds really silly. Like, duh, miss, why would I ever say that? Because we're saying that AC in one triangle has to be congruent to AC in the other triangle. Okay, so we have to say it. Now, the reason we're allowed to say it is by this property, the reflexive property, which says, duh, if it is one length, let's say it's 10 centimeters. If it's 10 centimeters in that triangle, it's got to still be 10 centimeters in that triangle. Duh, a 5-year-old would know that. Reflexive, right? You're the same as your own self. Reflection, like a reflection in a mirror, reflexive. You're the same as your own self. All right, well, that gives me a third side. Well, isn't that all I need to prove that two triangles are congruent? Sweet. So my ending, those were my logic steps. I really only needed one extra step. I almost had it with the givens. I just needed one extra logic step. I am ready for my proof statement. I have everything I need to prove that triangle, and my proof statement needs to be exactly like this. I have to write it exactly like this. ADC is congruent to triangle ABC. And we're going to say by side, side, side. You did a proof. Not too shabby, huh? All right, let's try another one. All right, C is the midpoint of BD. So notice I already wrote down the statement. What was the reason we used for that again? Given. Good. C is the midpoint of AE. Given. I always like to write those down just to be done with them. Now I'm going to go process. Remember I said my first step is always to draw? That's still true. So now that I've got my givens, I'm going to go draw. So if something's a midpoint, let's think all the way back to Unit 1. What does it mean to be a midpoint? Well, it means that you cut something in half. And when you cut things in half, those two halves have to be equal or congruent. How convenient. So if C is the midpoint of BD, I need to go find BD. BD is this line. So hold on just a second. Where's my mouse? Where'd it go? All right. So if C is the midpoint of this line, right, then BC, this little bit, and this little bit have to be the same, right? Whatever they are. Cool. So what would we say? We would say that BC is congruent to CD. Well, that's new information. They didn't give me that. I had to come up with that. I logically had to do things with my brain. So knowing what a midpoint is, I had to be like, oh, things. Okay, and I was able to know that this little piece is congruent to this little piece because I know what the definition of a midpoint is. Okay, so if I look back, I told you that these are the most common ones we are going to use right now. So definition of a midpoint is one of those. Okay, so we also have that C is the midpoint of AE. So we're probably going to have a very similar outcome. So here's the line for AE. So if C is the midpoint of this line, that means it also cuts these in half. But I have to be careful. It doesn't mean it's the same as the other one. So I have to give them different tick marks. I don't know that all of those little parts match. Right? So I have to be really careful about that. So AC is congruent to CE. Definition of midpoint. All right, let's stop and observe what we have so far. My givens didn't give me any sides or any angles, but my knowledge about midpoints did. So in this triangle, I have a side, right, and a side. It would be really helpful, right, to have an angle or another side. It looks like it would be really helpful if I had this angle right here. Do we know anything? Right? Because I have this side and I have this side as well. I got nothing about those sides, but this angle looks like something we've seen a billion times. You guys got any ideas? You're right. These angles are actually congruent. Let's talk about how we know that. So let's see if we can name them correctly. Angle BCA is congruent to angle ECD. Yeah, how do we know that? What's it called? Vertical. These are vertical angles. Alright, so now we have an angle. So, what order do these need to go in? So if I put an A right here, right? It's side, angle, side. Side, angle, side. Remember, we can't do ASS. That's not a thing. We can't do SSA. That's not a thing. Angle, side, angle. That is how I know that these triangles are congruent. Cool, cool. All right, we're going to have you try one. Press pause and give it a try. Because when I do this, I'm going to go pretty fast. All right, I hope you press pause, because here we go. Given LM is congruent to NO. Those are actually already marked. So I don't need to draw. Angle M is congruent to angle O, already drawn, so I don't need to draw it. So I currently have a side and an angle. Alright, it would be helpful to either have another angle or another side. don't have anything about sides, but I always have these vertical angles, right? I can always, 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 always choose vertical angles if I have them. So let's choose those and see if they're helpful. If I did, right, I would have angle, angle, side. That would be helpful. So angle, oh, I left a letter out here, didn't I? I think that's supposed to be a P. P. All right, angle MPL is congruent to angle NPO. How do I know? They are vertical. So that's angle, angle, side. So I can write my statement. MPL is congruent to triangle NPO by angle, angle, side. Victory. All right, we have one more. And then we're done. Here we go. You didn't think you would get away without using the word bisect, did you? It's not tough, I promise. Given that AC, so this is a segment, bisects an angle. Interesting. Given that AC bisects this angle, so that's a given, and that angle 1 is congruent to angle 2, that's a given. So let's go draw on our picture. If this line AC bisects angle DAB, so that's this big angle is bisected. What does it mean to bisect? Bi meaning two, sect meaning cut. I'm cutting it into two congruent parts. So this part has to match this part. I made those marks because I know what bisect means, right? Just kind of like the midpoint one. It didn't tell me this angle is congruent to this angle. It told me that it was bisected. I had to go think and figure out to put those. So I get credit, which means I get to write angle TAC is congruent to angle BAC because of the definition of bisector. Right? I get credit. I had to know what bisector means. It's not just given to me. I knew that. I get credit. Okay? Give yourself credit where you deserve credit. All right. Now, angle 1 is congruent to angle 2. They did just give us that. We don't get credit for that, but I do get to put marks. All right, let's kind of assess where we are. So we have an angle, check. We have another angle, check. Remember, angle, angle, angle is not a thing, so it would not help us to have another angle. We need a side. Anybody see a side? I see a side. I see a really easy side. Yeah, the reflexive side is always really easy to find. It's always a good one. Just kind of like vertical, you can always pick a vertical when they're vertical. You can always pick reflexive when it's reflective. So AC is congruent to AC because it's got to be the same as itself in the top triangle and in the bottom triangle. All right. Now, notice that I have angle, angle, side written this way, but that's not the order it is in my paper. So if I write it here, angle, side, angle, we have to be really careful. So it's actually here. All right, so the order that it is in my proof is not necessarily the order that it is. Okay, so we always have to kind of go back to our picture and see what the actual triangle property is. Okay? All right. You guys are awesome. I'm going to do this advanced problem really quick. Feel free to go work on your assignment. Go rock it. All right, advanced. You didn't think you were going to get to walk away from parallel and perpendicular. I guess perpendicular is not in this one, but parallel, did you? No. All right, you guys have been doing this for a while, so I'm going to bust through this. Here are my parallels. Those are my givens. AB parallel to DC, so this is how we write that. And AD is parallel to BC, so those get similar but different marks. So those are my givens. I put those on the same line because I ran out of space. All right, how could I know that angle 1 is congruent to angle 2? Based on parallel lines. Well, if these are my parallel lines, and this is my transversal, what is the relationship between 2 and 1? Oh. Alternate interior angles of parallel lines are congruent. Good. And then 3 and 4 would be similar, but they're with these lines. Okay? And this transversal. Okay? Alternate interior. Alright, so I have angle, angle. I'm sure you picked up, we need that reflexive side. So AC is congruent to AC. But, just like we said before, it's not angle, angle, side. It's angle, side, angle. Ta-da! Okay, so be prepared that you may have a parallel line proof show up in your assignment. Alright, you guys are awesome. Go forth and conquer. If I can ever find my mouse.